Okay, in the previous session, we had seen an example on register reference instructions. In that, let me quickly go and show you that example so that you can have a quick recap of it. In the question that was given to us, we were asked to execute all the register reference instructions one by one. We know that there are 12 register reference instructions, so all the 12 register reference instructions were to be executed one by one, and after execution of each and every instruction, we were asked to identify the value of uh, the registers AC, flip-flop E, PC, AR and IR. Okay, so some initial set of values were given to us. With reference to that, we had executed all the 12 register reference instructions and then had specified the values of the registers after completion of instruction. Now, in this session, we will be seeing how to execute the memory reference instructions. Okay, so let us quickly read the question given to us. An instruction at address 0 to 1 in the basic computer has I equals to 0. So let us first show this in the memory. Okay, suppose this is my address 0 to 1. We have said that the address is 0 to 1 and it has an instruction. So my instruction is over here. In the basic computer has I equals to 0. We know that the most significant bit is I, that is direct indirect bit, and it has value 0 in it. It indicates that this instruction is following direct memory address mapping. Then an opcode of the AND instruction. We know that AND instruction is a memory reference instruction and its code is 000. The first instruction of memory reference is AND, add, load, store, bun, BSA, IS These are the 7 memory reference IS Okay, these are the 7 memory reference instructions. We know that the code for AND is 000. This is 001, 010, 011, 100, 101 and 110. This thing should be known to you. Okay, fine. So now here we have said that this instruction has opcode of AND. So we wrote 000 over here and an address part equal to 083. 083 indicates that these are the 12 bits. This 083 is written in hexadecimal. Okay, so the 12 least significant bits are my address bits and these 12 bits are represented in hexadecimal form and hence we have written 083 over here. Now what else is given to us? Memory word at address 083 contains the operand B8F2. So you have again at address 083 we have B8F2. Again this is in hexadecimal. Okay. And the content of accumulator is A937. You are also said that you have your accumulator. Its value is A937 initially. Go over the instruction cycle and determine the contents of the following registers at the end of the execute phase. So after execution of these instructions, first we will start with AND. Why? Because my PC is pointing to this instruction and this instruction is an AND instruction. So first we'll start with AND and they are saying that repeat this 6 more times. Okay, so for all the other memory reference instructions, you have to repeat the same thing. After execution of each and every instruction, identify the values of these registers. Okay, so let us quickly start with it. We need to find the content of PC, AR, DR, AC and IR. Initial values given to us. We will first write out the initial values. Okay. Excuse me. We have said that the value of PC is 0 to 1. We know that the instruction is what? This 4 bits is 0 and remaining is 083. 4 zeros in hexadecimal is a single 0. Okay, so the instruction given to us is 083, but right now we have not yet fetched it. Initial values are given to us is of PC 0 to 1. AR is not given to us. DR is not given to us. AC is given to us, which is A937, and IR is not given to us. Okay, now we will start executing the instructions. Excuse me. So the first instruction is AND. We know that the instruction at location 0 to 1 is AND. As soon as the instruction is fetched, in the timing signal T1, we know that the value of PC gets incremented. So PC would become 0 to 2. What would be in AR? We know that the code for this instruction is 0083. During the fetch cycle, this 0083 is stored in IR. In the decode phase, these 12 bits, okay, would be stored in AR. So this will come over here. Then in DR, after execution of the AND, what happens in AND instruction? We know that I cannot carry out direct operation on memory and accumulator. So this M of AR we transfer to DR first, and then we perform the AND operation. Right? So these are the two steps which we'll be doing during the execution of AND. So after completion of AND instruction, my DR will have M of AR. Now what is M of AR? AR is 083. So M of AR is this one, B8F2. That would be stored in DR. And what will AC have? AC will have the resultant value after you perform AND operation between AC and DR. So let us quickly perform the AND operation between AC and DR. So what is the value of AC? AC is A937. So first we'll write it in binary. 1010 A, 9 is 1001, 3 is 0011, and 7 is 0001111. Okay, so this is my AC. Now, what is the value of DR? We know that operation would take place between AC and DR. So DR is B8F2. B is 1011, 8 is 1000, F is 1111, and 2 is 0010. Now let us perform the AND operation between these two. 100, 111, 0, 0, 1100, 0001, and 0101. Okay, so let us write its hexadecimal value. This is A832. So what would be the value of my accumulator after completion of AND instruction? It would be A832. IR we have already written. During the fetch phase itself, we'll be getting its value. Okay, so, fine. So that was AND. Now let us perform quickly add operation. Again, this instruction is executed keeping the initial values in mind. Okay, so these instructions are not in sequence. So we have to keep initial values given to us only in mind and accordingly execute all the remaining instructions. So again, when instruction add is fetched, the value of PC would become 0 to 2. After 0 to 1 पे add instruction होगी, the value of PC would be incremented and it would become 0 to 2. So what is the code for add? 1083. We know that this is add is 001. Indirect bit is 0. So it is 1. And piche in my AR 083 is given to us. So what would be fetched in IR? 1083. Okay. During the decode phase, what would happen? 083 would be stored in AR. Okay. Now add instruction again is performed between memory operand and AC, but I cannot perform operations directly on M of AR, so I'll first transfer it to DR, and then once the operand is in DR, we will perform the add operation. Okay, so again here also M of AR is transferred to DR. So what will my DR have? B8F2. AC would have the resultant value. So instead of AND operation, now here we will perform ADD operation. Let us perform the addition of these 2 AC and DR. 1 plus 0, 1. 1 plus 1, 0 over here, 1 carry. 1 plus 1, 0 here, 1 carry. Here I'll have 1. 1 plus 1, 0, 1 carry. Here. Again 1 plus 1, 0 here, 1 carry. Here 0, 1 carry. 1 plus 1, 0 here, 1 carry. 1, 0, 0, 0, again 0 and 1 carry. 1 plus 1, 0 here, 1 carry. 1, 1, 1, 1 plus 1, 0 and 1 carry. This carry is stored in the extended flip-flop E. Okay, and my AC will have these 12 bits. Okay, now here in this question, we are not asked to show the value of E. So, no need to write anywhere the value of E is 1. But we know that after the add operation, the value of E is 1. Now let us write the value of AC which is asked to us. So what would be the value of AC? This is what 1106, 2, 00102 and 1009. So after completion of add instruction, the value of my AC would become 6229. I assume you have understood this. So and add operation done. Now let us move on to the next instruction. So what is the next instruction? And add load store. Okay. So first let us write about load. LDA. What would be its code? 2083. So when load instruction is there, that instruction is fetched in IR. It would be 2083. Again, this is known to us. Last three, write it in AR. PC would become 022. Okay, what happens in load instruction? Load means what? From memory, you want to load it to accumulator. But memory to accumulator direct loading is not possible. So what we will do is, we will transfer M of AR to DR first and then DR to AC. So what would be the value of DR? Whatever is in M of AR. What is in M of AR? Is my operand B8F2. That will come to DR. And after DR, this value DR is stored in AC. So AC will also become B8F2. So this is my load instruction. Store. What is store instruction? Code would be 3083 instruction code. Okay. In store instruction, what happens is the content of accumulator should be stored to memory. Okay. Now, this thing can happen directly through bus. So we don't have any other registers into picture. Okay. So let us write the value. PC would become 022. Again, this during the decode phase itself would go to DR. Here, the transfer is taking place through bus and hence we are not using DR. So DR would be dash. Content of AC would remain same, A937, which was given to us initially. We are not changing the value of AC. We are just storing it to memory. Okay, so the value of AC would remain the same. Okay, so load store done. Next one is bun. Bun means what? You want to jump to a particular location. No need of returning back. It is like your go-to, okay, in C. So here, when an instruction says that bun 083, my next execution should start from that particular location. Okay, 083 से आपका execution start होना चाहिए. So if you want to start your execution from location 083, this value should be stored in your PC, right? So what would be the updated value of PC after completion of bun instruction? Whatever was my address, the code for bun instruction is 4083. This 083 is stored in AR and this AR is transferred to PC because I want to start my execution from this point. Okay, so this is 083. 083 would be stored in your AR. Again, that AR is copied to PC so that execution start from that location. So PC would also become 083. We are not touching DR. So DR would be dash. AC would remain as it is. I assume you are getting this. Okay. Next is BSA. BSA, again, the code is 5083. What does BSA stand for? Branch and skip branch and save return address. I'm so sorry. Branch and save return address. So in bun, what we were doing is we are going to a particular location and not returning back. It was like go to. But what is BSA? BSA is like your function call, where we will jump to a particular location and then come back with the help of return statement. So what happens in BSA? First of all, if your instruction is like this, 0 BSA 083, you jump to 083 first, store the value, store your return address. Initially PC is 21. After this instruction is fetched, PC would become 22. So what is done in this BSA instruction? This PC is stored at location 083. So PC की value इधर आ जाएगी. And then your subroutine is starts from location 84. So what we need to do is we need to first store PC to 083. Then in the same step, what we will do is we will increment the value of AR. Why? Because we know that our subroutine starts from 84th address and I want the PC to start my execution from 84. So what did we do? We incremented the value of AR. Now it is 84 and this incremented AR is stored to AC. So what would the value of PC become? 84. If PC is 84, then only your execution will start from here. I want my subroutine to be executed, right? So the PC is 84. So here what we will write? 84. What is the value of AR? AR has also been incremented. So AR is also 84. Are we using DR here? No, we are not using. So place a dash. Is the value of AC changed? No, it will remain the same as the initial values given. Okay, so this is BSA. And last instruction is ISZ. The code for it is 6083. Okay. First step 083 will be stored here. Okay, what is ISZ? Increment and skip if 0. What do we need to increment? We need to increment the memory word. Okay, I cannot increment the memory word directly. So first step is what? I will be storing it to DR. Then what we will do is we will increment DR. So DR is incremented by 1. Now we will check the value of, okay, this DR is incremented. Now, what we need to do is we need to increment the memory word and then check if it is 0, skip the next instruction. So here, in the first step, we are bringing memory word to DR, we are incrementing it, we are incrementing the DR and then we are storing the memory word back to its original location, and simultaneously what we are doing is we are checking if DR is 0, I need to skip PC. PC equals to PC plus 1. Okay, so here what will happen? 6083 was my instruction code. This AR is stored here during the decode phase. Now what we are doing is we are fetching the operand and storing it to DR. So DR में क्या आएगा? B8 F2. Now what happens is we are incrementing DR. So what would DR become? B8 F3. This AR is stored in, here what we are doing is, ये पुराने instructions here, sorry. This is the last one which we did. Okay, so here DR has become B8F3. Now this DR is restored back to memory and here only we are checking if value of DR is 0, PC को increment करो. PC तो क्या था अपना, as after the fetch instruction PC is 0 to 2, initially it was 0 to 1, fetch के बाद 0 to 2 हो गया. So after this it is checking, अगर DR 0 है तो make PC 23. But is our DR 0? No, it is not 0 and hence we will not change the value of PC. The content of accumulator is not touched, it is as it is, so it would be A937. I hope you have understood ISZ instruction. Incrementing the memory word. Memory word is brought to DR and hence we wrote it here. Then we incremented DR, so DR is B8F3. We restored it to memory. हमें memory में क्या update हो रहा है that we are not asked to show. So we are not showing the content of memory. But the value of DR is B8F3. This is not 0. So PC will not be incremented. It would remain the same as it was after the fetch phase. Okay. So this is the list of all the memory reference instructions and the value of the different registers after execution of each and every instruction. Okay. I assume that you have understood this and you do not have any doubt in it. So when this type of questions are asked to us, start with the initial value, write the instruction code for each and every memory reference instruction, and then if you know what steps are being executed in each and every instruction, then only you will be able to write the value of DR and other registers given to us. In some of the instructions, we are not using DR. So in that case, we are placing dash over there. Okay, so if you know the steps that are being taking place in each and every instruction, then only you will be able to complete this table.